G'day. This time we have a very simple trig function to be integrated. Now it's complicated a little by some constants, but if they weren't there and we were just integrating sine theta, I don't think we'd have a great difficulty with it. We know the answer is going to be a cosine of theta. But how do we handle these two constants? Well, one way would be to substitute, and to substitute a u in place of 2 theta, so we'd end up with sine u and everything would resolve nicely. We may do that later in the video. I'm doing this just off the cuff, so if I decide we've got enough time, we will. The other one's to look at a pattern. We actually have sine of a function of theta. Now when we know that the answer is going to be a cosine, so let's imagine if we start with finding the derivative of a cosine of a function of x, because that's the direction we're heading, what do we get? Well, the derivative of cos is minus sine of fx times f dash x, because we're using the chain rule. Derivative of cos is minus sine, and the derivative of fx is f dash x. If we multiply both sides by dx, I'm going to do that this way because I can on a whiteboard. I hope I haven't run off the side here. If we integrate both sides, the integral undoes the derivative, and this is the pattern we're looking for. Now we have sine of a function, and the derivative, we want the derivative out the front. The derivative of 2 theta is 2 rather, not 3. So let's start manipulating. I'm going to move the 3 out the front. Get my red pen. So far they're identical. Just moving the 3 out the front won't change the result. But to get our pattern, there's our function, sine of some function. We want the derivative as well. The derivative of 2 theta is 2, and I must compensate for that by multiplying by a half. I'll just underline that with 1, underline that with 1. And the other part of the pattern we need is a minus sign. And if I put a minus sign in there, this is multiplied, I need a minus sign out the front because a minus times a minus gives a plus, still makes no difference to the result. And that will give me minus 3 on 2 times this integral. Now we've manipulated this integral to exactly follow this pattern, and the answer is cos of whatever that function was, cos of 2 theta plus c. Now I happen to like putting the 2 under the whole lot, so we'll do that. And that's how we would perform that particular integration. Now, I think we might have time to do it by substitution. So that's always instructive. And by the way, when you're studying, I have trouble writing and talking at the same time. When you're studying and when you're practicing, it's a very good idea on occasions, and sometimes on quite a few occasions, to try to solve the same problem 2 different ways or 3 different ways. First of all, to confirm that you get the same answer every time, but also to gain experience and versatility with different methods. Here we're going to substitute u in place of 2 theta. So we let u equal 2 theta. That means du, I'll get out of your road here, du d theta would be worth 2, and multiplying both sides by d theta would give du equals 2 d theta. Or if you like, du divided by 2 would equal d theta. Just dividing both sides by 2. What do we get? Well, we get the integral. We can leave the 3 here if we want, or move it out, it doesn't matter. Now we have sine of 2 theta, but 2 theta is worth u, so we have sine u. And in place of d theta, we can write du on 2. moving the 2 out the front, we have the integral of sine u du. So that's 3 on 2. Now the integral of sine u is minus cos u. So I'm going to put the minus out here, cos u plus c. And I think you can see I don't have any room to go down. But if I replace the u with 2 theta, and I extend that across, you can see I have the same result. So they're both good methods. They're both an issue of personal preference, or sometimes the complexity of the problem at the time. Whether you follow what I call the pattern or whether you substitute is entirely up to you, and I encourage you to experiment with both. But I hope you found that useful, and thank you for watching.